Do you guys still remember from last year how to find the inverse matrix of a 2 by 2?
Didn't you like switch it and then make one of them like?
Yes. Yeah. And then we had to find the determinant, which has to do with that ribbon that we were doing. Yeah. Okay. So, for example, if we have the matrix A, B, C, D, and we want to find the inverse, the negative one means inverse. Okay, so if we have A, B, C, D, we want to find the inverse. First of all, we got to find the determinant. Okay, so determinant of a 2 by 2 matrix. So recall from last year, we said we're going to do a ribbon, but this ribbon is going to be the opposite of how you see ribbons usually. So we're going to start with A, and then we're going to go down to D. That means A times D. And then we're going to turn it back around a little bit. That means minus sign. And then we're going to go to C and then cross over to B. So that means C times B. So AD minus CB is the determinant. So the determinant of a matrix is just a specific number that's associated with that matrix. For a 2 by 2, you do this ribbon that's backwards, AD minus CB. All right, so we need this determinant to find the inverse matrix. So the formula for an inverse matrix is 1 over determinant, which you had to find by AD minus CB. And then you are going to do something kind of in that order as well. AD, we're going to switch AD. So it's going to be D and A like that. Switch AD. Then we're going to make BC negative. Okay, all right, again, 2 by 2 matrix. If you want to find the inverse matrix, first you have to find the determinant. AD minus CB. Okay, that goes into the 1 over determinant part. Next, you're going to switch AD and then make BC negative. And then when you multiply that all together, that is the inverse matrix. Okay, let's practice. So let's go all the way down to the bottom. 3, 1, 4, 2. Okay, first let's find the determinant. Okay, use the ribbon. So what are the two numbers when we multiply together and then minus what two numbers multiply together?
3 times 2 minus.
Yeah, 3 times 2 minus 4 times 1. 6 minus 4, which is 2. So the determinant is 2. Now, if we want to find the inverse matrix, we need to take 1 over the determinant. All right, which two numbers did we switch? 3 and 2. And then which two do we make negative? 4 and 1. Okay, do not switch 4 and 1, okay? Just make them negative. The last thing we're going to do is we're going to take that scalar, which is 1/2, we're going to multiply in. So 1, negative 1/2, negative 2, 3/2. And then we're done. So that is the inverse matrix of A. Again, find the determinant, take 1 over determinant, switch AD, make BC negative, and just multiply all together. Good? Just a little review of last year. All right, now let's do 3 by 3. 3 by 3 is a lot bigger. Now, 3 by 3, I'm not going to make you do the inverse matrix, but I do need you to find the determinant. You're going to find the inverse matrix using your calculator, so make sure you have your calculator today. We're going to use calculator a lot. For now, Let me just remind you how to find the determinant. Do you have your calculator? Oh no. Okay. All right. So to find the determinant of a 3 by 3, first copy the first two columns to the right. So the first two columns, just copy it over. Next, we are going to go down the diagonal from the top left to the bottom right. Do you guys remember?
Yeah.
Okay, so we're going to multiply all the elements down the diagonal. So once you multiply, you write the the product there, product, and then product. So you're just multiplying all the numbers, whatever the numbers are, multiply and then put it on the bottom. You're going to add them together. Next, you are going to find the other diagonal. This time, you're going to go from the bottom left to the top right. You're also going to multiply the numbers together and then write it on the top. Okay, so first, top left to bottom right, and then bottom left to top right. Okay, you're also going to add them together. The determinant is the blue ones, the sum of the blue ones minus the sum of the red ones. So basically, you're going to subtract out all of the top ones. Add the bottom, subtract the top. And that's going to give you a 3 by 3 determinant. And you can do that for 4 by 4, 5 by 5, or anything bigger than 3 by 3. Okay, sorry. Make sure everybody finished copying. Okay, you guys are good? Not yet? Okay, so we're going to try finding the determinant using just our algebra skills, and then we are going to use our calculator to check. Okay, so let's go down to B. Let's find the determinant of this 3 by 3 matrix. What do we need to do first to find this determinant? Copy what?
First two columns.
Okay, first two columns, we're going to copy it over to the right. So 1, 2, negative 1, 2, negative 1, 0. Okay, let's let me call somebody to answer. Peter and Raymond, what should we do next? Yeah, diagonal from which side to which side? Left to right, from top to bottom, right? Okay, so now that I draw a diagonal, what am I supposed to do? Multiply them together. Negative 1, negative 6, 0. All right, Gary and Jingyi, what should I do next? Yes, but before then, I have these negative 1, negative 6, 0. What am I supposed to do with these numbers?
Add them up.
Yeah, add them up. All right. Next, Murphy and Raymond, what should I do next?
Multiply from the bottom left to the top right.
Yeah, bottom left to top right. And then what should I, okay, so I'm going to multiply them. So negative 1, 0, 4. Philip and Lisa, what should I do next?
And add the negative 1, the negative 2, and 0 together.
Yes, good. All right, let's see. Sunny and Daniel, what should I do last? What's the last thing to do to find the determinant?
Oh, the blue ones minus the red ones.
Yeah. Good. Blue ones minus the red ones. So this is going to give me negative 7. This is going to give me 3. So negative 7 minus 3 is negative 10. Okay, so negative 10 is the determinant. Now let's use our calculator to see if we get negative 10. So everybody has to have a calculator. If you don't have one, and we'll be nice and lend it to you today.
Thank you.
Everybody has a calculator, right? All right, we're going to find the matrix function on our calculator. Okay, you're going to go to second, and then you're going to go to the x to the -1 button, because on top of that it says matrix. Okay, and then in this matrix function, you have 3 different things you can do: name, math, and edit. We're going to go to edit. So scroll all the way to the right to edit. You have a lot of matrices you can edit. We're going to just choose the first one, which is A. So press enter. It's going to ask you the size of the matrix. Well, we want to calculate for B. B is what size? 3 by 3. So you're going to put 3, enter, 3, enter. Yeah. Edit. You have to go to second matrix. Second x to the -1, that's going to be matrix. And then you'll have on the top, it says name, math, edit. Peter, can you help Raymond if you can't find it? All right, now that you have a 3 by 3, you will see 3 rows with nothing in there or zeros all in there. Just type in all the numbers. Once you type in a number, just press enter, and it'll go to the next number in the sequence of the rows. Question?
No.
Oh. Okay, so enter all 9 numbers. Enter all 9 numbers. So just press enter, it will go to the next element. You're trying to figure out how to use yours. There's a matrix somewhere. I forgot. All right, now that you entered everything, you're going to exit this matrix frame. You can go to second, mode. It says quit on the top, so it would just go back to the calculation frame. Mode is right next to second. All right, so now that you're here, we're going to do something with this matrix. So we want to determine it. All right, so we're going to go back to second matrix. Right, so we're now going to go to math. Underneath math, you'll see one that says DET. DET means determinant. So press that button. Enter, and then now you're in the calculation frame. It says DET parentheses. You're going to go back and tell them which matrix you're going to choose. So second matrix again. This time you're going to go to name because you're going to use this matrix. So you're going to use name, okay, and then choose matrix A. That's where you store that matrix. Enter, and then it says DET A. So press enter again. It should give you -10. Okay, if you type all 9 numbers in correctly. Yes, good? All right, so that's how you use it. Okay, we're going to do the same thing, except this time we're going to find the inverse matrix. So because I don't want you to do this by hand, I want you to find the inverse matrix using the calculator. So you are going to do this. You are going to go to second matrix. Okay, you're going to select A. So in name, you're going to just select matrix A. So then in the calculation screen, it just says A. Mm-hmm. You want the inverse. Inverse is the -1 button. So you're going to just press X to the -1. And then enter. And then that should give you a 3 by 3 matrix that's all inverse. Yeah, so you can double check with your calculator for like a 2 by 2, things like that. Make sure you know how to do it because pretty much from now on, we're going to use the calculator for more I mean, harder stuff, you really don't want to solve 4 by 4 by hand, so you have to use the calculator. That's crazy. Yeah, your calculator is pretty powerful, and that calculator is very powerful. It factors for you. It multiplies polynomials.
What?
Yeah, that's a crazy calculator. Which one? All right. Okay, the reason we are doing inverse matrix is there's a fast way to find out if something has the inverse. All you have to do is check the determinant. If the determinant is 0, there is no inverse. If the determinant is 0, there is no inverse. So if someone asks you, is there an inverse to this matrix? All you have to do is find the determinant. Is it 0? If it is, no inverse. If there's a number, then there is an inverse. Okay? All right. Last thing we're going to do, which is we still need to use our calculator for this, is we're going to transpose matrix. All right, transpose. So transpose matrix is very easy. What it does is if you have a row by column matrix, transpose matrix, so let's say that you have a matrix that is row by column. When you transpose a matrix, that means you put this T on top of it. You're basically just switching it so it's column by row. So for example, if you have 3 rows by 1 column, if you transpose it, you're going to have 1 column by 3 rows. So it's just switching it so the size is a little bit different, but the elements are the same in there. Okay, so that's transposing matrix. If you want to transpose a matrix by hand, then here's what you do. So let's say that you want to transpose this matrix. You are just going to find a mirror image of the matrix. Okay, so what does that mean? Down in the middle, that diagonal is the mirror. What you're going to do is you're going to flip all the elements across from each other across the mirror. Does that make sense? So down the diagonal, that is the mirror. The mirror doesn't change. So the mirror is 1, -1, 1. What you're going to do is flip the elements across the mirror. So there's 2 and there's 2 switches, but they're the same number, so not very interesting. There's -1 and -1 switches. Sorry, I gave you the same number, so it doesn't really matter. There's 0 and 3 switches. Okay, so the mirror doesn't change. You flip the elements across. And that basically switches the row and the column. So basically kind of like if you tilt your head this way, that's kind of how the numbers are gonna end up. So you're just switching the row and column. All right, so the question is, why are we doing this?
What if it's not 3 by 3, it's like 3 by 2?
The mirror is a little different. You're basically just switching the row and column. So you're gonna make it if it's like a 3 by
You can do that on calculator.
yes, you can also do it on calculator. So 2 by 3, you're gonna switch it so it's now 3 by 2, and then just swap all the rows and columns.
Oh.
All right, so the reason we're doing this is we have an application question. Let me find here. Here we go. All right, a florist makes 3 different cut flower arrangements for Mother's Day. 1, 2, 3, each involving roses, carnations, and lilies. Matrix A shows the number of each type of flower used in each arrangement. Okay, so And I'm going to give you these. So this is roses. This is carnations. And this is lilies. And this is arrangement 1, arrangement 2, arrangement 3. So how do you read this? This means arrangement 1, so like some kind of arrangement, uses 5 roses, 6 carnations, 4 lilies. Arrangement 2 uses 8 roses, 6 carnations, 3 lilies. Arrangement 3 uses 7 roses, 7 carnations, 3 lilies. So this is how you read it. Of course, you can read it this way too, but vertically might, make more sense in data. All right, so that's the first part. Second part, the florist can buy his flowers from 2 different wholesalers, W1 and W2, but wants to give all his business to one or the other. The cost of the 3 flower types from the 2 wholesalers is shown in matrix B. Okay, so let me give you the name as well. Roses, carnations, lilies. Okay, and then that is wholesaler 1, wholesaler 2. Okay, here's how you read it again. Wholesaler 1 sells roses for $1.50 each, carnations for 95 cents each, lilies for $1.30 each. Wholesaler 2 sells roses for $1.35 each, carnation for $1 each, and lilies for $1.35 each. Okay, good? Let's see what the question wants us to do. Construct a matrix showing the cost of making each of the 3 flower arrangements from flowers supplied by the 2 different wholesalers. Okay, they want the cost of each arrangement by wholesaler type. So how much would it cost for wholesaler to make arrangement 1, to make arrangement 2, make arrangement 3? And how much does it cost for wholesaler 2 to make arrangement 1, arrangement 2, arrangement 3? You do need to multiply. You do not need matrix, right? You could just calculate, right? It's just like intuitive math. But matrix is faster once you know how to do it. Okay, so we know we're going to have to somehow multiply these things together. But let's look at the size first. What is the size of matrix A? 3 by 3. What is the size of B?
3 by 3.
3 by 2. 3 by 2. Okay, so my question is, can I multiply A and B?
Yes.
3 by 3 and 3 by 2? Yes and no. Yes, the numbers work. However, let's look at why it doesn't make sense. Okay, so let's look at A. 3 by 3 matrix. Let's look at the categories of each row and column. What's the category for the row? What are we looking at? What does row represent? Types of flowers, so flowers. What does the columns represent? Number, what kind of number? Arrangement, yeah, arrangement. Okay. Matrix B. Sorry about the lag. Matrix B. 3 by 2. What does row represent?
Flowers.
Flowers. And then what does column represent? Not price. Wholesale. Okay, now let's look at multiplying them. So 3 by 3 times 3 by 2 looks nice. We can do it. However, let's look at the category. So this is flowers times arrangement. This is flowers times wholesale. So you can see that the 2 in the middle are actually not the same kind. So you cannot multiply them together. What can you do to make them multiply? Do the T thing.
To the first one.
to the first one. So if I could make the flowers match in the middle, right? If I can make them match in the middle, then I can multiply them together. And to switch row and column, I use transpose matrix, right? So transpose matrix is to switch the row and column. So what I can do is do A transpose times B. I'm still keeping my 3 by 3 and 3 by 2, but this time my row and column switches. Right, so now the flowers are meeting in the middle and I can multiply them together. Let's talk about what matrix I'm going to get at the end. So if I multiply them together, what is the category of the matrix I'm getting at the end? Arrangement times wholesale. So arrangement type by wholesaler. So and then in the middle I have all my price. Right?
Okay.
Yeah? Okay, so now you're going to use your calculator to do all that stuff for you. So you're going to type in matrix A, matrix B in your calculator. Okay, matrix A, matrix B. And then I'll show you how to do the A transpose B. Yeah?
Can you multiply matrices in your calculator? Like
Yes.
Do it for you?
Yes.
Okay.
Yeah. So go ahead and type in A and B and I'll help you with the rest. So I'm going to show you what to do next. You're basically going to type in this whole thing in the calculator. So select matrix A like what I showed you before. Okay? So go to matrix and then select name and then A. Go to the second matrix and then select A. And then you're going to go to second matrix again. This time go to math. When you go to the math button, there is one of the selections says T. That means transpose.
Can we just, when we type in A, we just type the...
Yeah, if you transpose in your mind, you could.
Okay.
Yeah. And then go back to matrix again, and this time select B. You don't have to put multiply in between, and then just enter, and then we'll give you a 3 by 2 matrix. All right, copy down that number. We are going to look at what this matrix means. All right, you should get this matrix that is 3 by 2. What does the row mean again? No. Arrangements, I think. Okay, so 1, 2, 3. And then what does the column mean? Wholesale. All right, so how much does it cost for wholesaler 1 to make arrangement 3? No, wholesaler 1 to make arrangement 3. $21.05, right? Okay, so this is how you read this whole matrix. And it's much faster to do it this way, right? Of course, you could have calculated all this, by hand. But if you put it in matrix, it's a little faster. But of course, you are just first seeing this, so intuitively, you're not going to go to matrix, but just know that this is available for you to do. Okay? Any questions on transposing? No? Okay.